Hi friends, welcome back to my channel. This is Mr. Chutke helping you with the fundamentals of chemistry. So today we are going to see what, why and where of chemistry. Now first things first, what is chemistry? Now even if I ask you to define chemistry, most of the children will get a little baffled with what is exactly chemistry. You may think about reactions, you may think about elements, you may think about compounds, but what does exactly chemistry deal with? So this is, I would say, the foundation session of the what, why and where of chemistry. So talking about what is chemistry, here I would like to take you for a ride into the universe. And here in the universe you'll be able to see mega objects like the sun is 13 lakh times greater than the earth, and there are some stars which are even greater than the sun. So this sun or these stars or these mega objects, what are they made up of? They are made up of ultimately matter, and we know that matter is anything that occupies space. Ultimately it is made up of atoms, elements, molecules, compounds. So it ultimately drops down to chemistry. Okay, and even if you talk about the mega objects or even the smallest or the tiniest objects, which is like the atom or the subatomic particles, again then that also comes under chemistry. So it all, our universe is said to start with the Big Bang theory. So in the Big Bang theory it is said that in the center there was an explosion from the sun, and particles blew away from the sun, and they started moving with the speed of light, or probably this greater than the speed of light. And when any object travels with the speed which is greater than the speed of light, it may have a tendency to lose electrons, protons, neutrons, and that's how new elements were formed, like fluorine, then neon. You can say neon became fluorine, fluorine became oxygen, oxygen became nitrogen, and so on. Okay, so that is again a theory. Then the universe is the totality of existence. It includes, as I told you, the mega objects like planets, stars, galaxies, and even the subatomic particles. So all this is coming under the universe. Okay, and shall we go to our solar system? So here is a view of our solar system. We are having a total of 8 planets. Okay, because Pluto is discarded as a planet, so therefore 8. And in the sun, in the center we are having the sun. So falling back to the earth, even on the earth, whatever you can see and whatever you cannot see, all that is made up of matter. And we have discussed earlier that matter is anything that occupies space, and again it is made up of molecules, elements, atoms. So it's all revolving around chemistry. So what is exactly chemistry? It is the study of composition, then properties and structure. Now say for example, even if you talk about just a piece of chalk. So chalk, the composition of chalk is calcium carbonate, CaCO3, 1 atom of calcium, 1 atom of carbon, 3 atoms of oxygen, CaCO3. That's the composition. Properties, you may say it's white in color, it reacts with acid to release hydrogen gas or carbon dioxide gas. Then other properties is insoluble in water. So you can go on these properties. So study of the composition, the properties and the structure of CaCO3. Now if I show you the structure of CaCO3, it can be something like this. Now CO3 carbonate is C double bond O, C single bond O, and C single bond O, because carbon is having 4 electrons in the outermost shell. So that's the maximum electrons which carbon can give to oxygen. Remember, oxygen is the world's second most electronegative element. So this oxygen is not satisfied. This oxygen is satisfied, therefore no charge on this oxygen. This oxygen is again not satisfied, these two, because they've received only one electron, whereas oxygen, you know that oxygen is having an atomic number of 8 with an electronic configuration of 2,6. It requires 2 electrons to complete their octet. So it is requiring 2 electrons to complete their octet, but they have received only 1 electron. So how will they satisfy themselves? So if I attach calcium over here, calcium is ready to give 2 electrons, and that's how calcium, after giving 2 electrons, these oxygens will become stable. Okay, these oxygens will become stable and the structure will become CaCO3. And the composition, properties and structure, and then after that transformation of matter from one form to the other, like CaCO3 after heating, okay, is forming CaO and CO2. So CO2 is a gas. So what is happening? That transformation of matter from one form to the other, all this is called as what? Chemistry. That is the study of composition, properties, structure, transformations. All this will come under chemistry. So this is about what is chemistry. Now let's move on to where is chemistry. Now chemistry is there in the fragrance of roses. Geraniol is a chemical which is giving the fragrance, which is imparting the fragrance to roses. Then we are having, say for example, these bright colored flowers. Okay, the pigment inside the flowers, or the pigment in plants, that is chlorophyll. The pigment over here, phycobilin, xanthophyll, yellow in color, carotenoids, orange or reddish in color. So all these are pigments, and all of them are chemical compounds which are imparting colors to different, you can say, plants and organisms. So that is coming under chemistry. The touch of a flower, that touch of flower is wax sorry, waxy and smooth. So because it is waxy and smooth, you can actually feel that softness of the flour. It is again because of chemistry, because wax is a chemical compound. Then if you talk about the most important substance, that is which we cannot live even for a minute, that is oxygen. That oxygen will also come under chemistry. Another essential compound, that is water. Okay, so this water, H2O, is also a chemical compound. So what we can say, that chemistry is not only in nature, it's rather everywhere, even in the man-made objects. Okay, just like the laptop, you may using a mobile for viewing this video. So that mobile, that laptop, all that is also made up of chemical compounds like silicon and other elements and compounds required to make that laptop. Now you must be viewing this on a Wi-Fi network. So the Wi-Fi network is again made up of, like, optical fibers are made up of carbon nanotubes, that fullerene. Okay, so that is also made up of, that is also, your Wi-Fi network also requires chemistry. Then treatment of thyroid requires an isotope of iodine 127, that is also coming under chemistry. Then cancer treatment, that is cobalt 60, that is also coming under chemistry. So what we can say, that chemistry is everywhere. Rather, there is not a single place where you won't find chemistry. Okay, so chemistry is everywhere. Now the third is, why is chemistry, why one needs to study chemistry. So we need to study chemistry because chemistry has made our lives easier. You see the walls around you, they are having paint. So paint is again coming under what? Chemistry. You cannot make paint without learning chemistry. Okay, without learning the basics of chemistry. Then our personal hygiene, soap, then detergents, all these also are chemical compounds. They have been refined by a lot of research, surfactants, surface active agents, making of the bipolar molecules. All that is requiring, you would say, chemical engineering. So that is coming under chemistry again. Then carbon fiber, this is something which will I would say impart hardness. It's 3 times more harder than steel. So you can coat your helmet and cars with this carbon fiber, which is more stronger, 3 times more stronger than steel. Now photography. Okay, now I would like to ask you a question. Which is the world's most costliest camera? Some of you may say Nikon, Sony, or maybe some other brand, but I would say that the world's most costliest camera is your eye. Yes, the design of this camera is also been inspired by the eye. This camera has a shutter, your eye also has an eyelid. This camera has a lens, even your eye does have a lens. So your eyes are precious, rather they are priceless. Okay, so the idea of photography is again developed from the eye, and that is also coming under chemistry. While you're viewing this, you are able to see this video because there is rhodopsin, a chemical in your eye, which is splitting into rhodon and opsin, and that's the reason why this image is reaching your eyes. So again, a chemical reaction is going on in your eyes and again in your brain, so that you are able to view and understand what we are doing over here. So chemistry is required for printing the picture. Chemistry makes the film. Then moreover, the thing which girls love, that is cosmetics. Okay, so these cosmetics have also you can say chemistry has an important role in making of the cosmetics. Not only this much, but even shampoos, two-in-one shampoos, toothpaste. Okay, earlier we used to brush our teeth with twigs or maybe datun, what is called as datun. Okay, a wooden bark, a small wooden bark, you can say. So then we have developed slowly and steadily, we developed certain formulations, that is toothpaste, which cleanses your buccal cavity. Again, it is what? It is having chemicals, calcium carbonate, a mild abrasive, then sweetener to give you, to impart a better taste, menthol to improve the freshness of your mouth, deodorant, and many other things are imparted into the formulation of toothpaste. So again, chemistry has played a very important role in are making our lives a little more easier and also healthier, because now this is medicinal chemistry, isn't it? So all our medicines are either coming from nature, or they are coming from our labs, chemical labs. Okay, so research of medicines, building better medicines, has increased the life expectancy right from the age of 25 to 60 now. Okay, so you can see that chemistry is playing an important role even in the pharma industry and also in our agriculture industry. Like, to get better crops, we need to spray pesticides and fertilizers, so all that also require chemistry. Here are the branches of chemistry, like organic, inorganic, physical, biochemistry, analytical chemistry. All these are the branches of chemistry. So in organic, we study about the hydrocarbons, and we study about the things which are obtained from plants and animals, basically. So hydrocarbons are there in plants, furniture, whatever is obtained from plants and animals will come under organic chemistry. Okay, and also, like, plastic is also, the idea of making plastic is also come from plants, right? So alkenes, that is, so that plastic is also coming under hydrocarbons and coming under organic chemistry. We cannot imagine our life without plastic. And inorganic chemistry deals with elements, salts, acids, water. All this comes under inorganic chemistry. Then we are talking about physical chemistry. Physical chemistry deals with the exchange of energies, like thermodynamics, kinetics, speed of the reaction. Equilibrium will give you the extent of reaction. Dynamics, thermodynamics will tell whether the reaction can be carried out or not carried out, whether it's feasible or not feasible. So all these things come under the physical chemistry. Chemical bonding, atomic structure, all this comes under physical chemistry. Then, talking about our chemistry of our cells, like our cell is made up of carbohydrates, so the structure of carbohydrates, structure of proteins, structure of lipids, vitamins, nucleic acids, DNA, all this comes under the study of biochemistry. Okay, so now another branch is analytical chemistry. Now, a branch of analytical chemistry you've watched and admired a lot, that is the CID. You must have watched the CID program, and in there we are having forensic chemistry, which is a branch of analytical chemistry. You have heard that famous dialogue, "Daya kuch to gadbad hai." Okay, so in that we have seen that Dr. Salunke is, kind of analyzing a hair, and with the DNA of that hair, he can tell who has committed the crime or who has committed the murder. So analysis related to crime is forensic chemistry, but analysis of blood, analysis of urine, checking blood pressure, analysis of salts, which you actually do in your laboratory, so all that is coming under analytical chemistry. Rather, your entire practical chemistry comes under analytical chemistry. Then chemistry also extends its branches to all aspects of our life, that is agriculture, environmental science, biological, forensic, pharmaceutical, medicine, metallurgy. Extraction of metals also requires chemistry. So this was my attempt to give you a small gist and generate some interest in the subject chemistry. All the best for your